So we've got a buoyancy problem here, and it's important to understand some definitions, right? So when it tells you the weight of something, that's mg, and for fluids that means rho vg, right? So the density of the object times the volume of the object times g. In this case, that's 755 newtons. And then it tells you that it weighs 532 newtons when completely immersed in water. We also call that the apparent weight, which is just the gravity minus the buoyant force, right? Like your apparent weight in water, for example, is 0, and that's because your gravity is equal to the buoyant force. So that's rho of the object times the volume of the object times g minus the density of the fluid displaced times the volume of the fluid displaced times g. That's equal to 532. Okay, so what I'm going to do is I'm going to take 755 and I'm going to substitute it in right here for rho, for the density of the object times the volume of the object times g. So 755 minus the density of the fluid times the volume of the displaced fluid times g is equal to 532. Now I'm going to make another substitution, which is that the, well, actually I don't have to make another substitution right now. I'm just going to write down what I know here. So 755, now the density of the fluid is 1,000, okay, times the volume of the fluid displaced, and then 9.8. That's equal to 532. So I get the volume of the displaced fluid is minus 223 over minus 9,800, which is 0.0228 cubic meters. Now, since it is completely immersed, that's another little English phrase that we have to translate into mathematics. That means that the volume of the water displaced, or the volume of the fluid displaced, is equal to the volume of the object. So the volume of the object is 0.0228 cubic meters. Okay? That's the first answer we were looking for, the volume of the block. Next, we need the density. Right? Well, we can go back up here where the density of the object times the volume of the object times g is equal to 755, and we can start plugging in what we know. So the volume of the block we now know is 0.0228. Right, and if I solve this for the density of the block, I get 3,400 kilograms per cubic meters. Now that makes sense because I would expect that when the object is immersed in water, if it still has a weight, then that means it would sink. So I would expect that the density would be greater than the density of water, so 3,400 makes sense.